Good morning, everybody.
Morning.
Okay, welcome back.
Good
So, how are you
morning.
all today?
Good. Thank you.
Okay, so today we are going to begin the seventh unit of this course. You can see we are winding down so fast. We have three more units. Okay, after seven, it's 8, 9, 10. So you can see that we are moving towards the end of the semester. So make sure you keep checking your grades, find out where you're at, continue what you're doing, completing your assignments and things like that. Okay. So here from this chapter, you'll see that what we'll try to do is we are slowly working on the inferential statistics, meaning how we can use the simple statistics to inform about the population. That's what we are doing here. So if we have the idea about the sample, what we can say about the population, okay, what we can predict about the population, that is something we'll be studying in this chapter. And the first idea in this chapter is the confidence interval. There are several different cases of confidence interval, but before we get into those different cases of confidence interval, we are going to look at some basic terms related to the confidence interval. The first one is the point estimate. So when I say point estimate, it is the specific numerical value estimate of the parameter. So whenever we are constructing the confidence interval, because in this chapter we'll be constructing the confidence interval. So for example, let me draw something here. If I construct an interval like this, if I construct an interval from here, say for example from A to B, if I construct an interval from A to B to talk about the parameter, to talk about the population parameter, okay, then what we have is we have some value in the middle. In the middle, we'll have some value. We get some value in the middle, and that is from the sample. And that value which goes in the middle of the interval, that is called the point estimate. That is called point estimate. So you can add this to your note catcher. Now, if you read the definition, this will make more sense. A point estimate is a specific numerical value of a parameter. So if I want to estimate the mean of the population, say for example, if mean lies between these two values, if mean lies in this interval from A through B, I don't know what is exact population mean, but what I'm doing is I'm saying that mean lies in this interval. Okay, I'm saying that mean lies in this interval from A through B. Then the value that goes in the middle, that is called the point estimate. And remember, the point estimate is the value from the sample. If I want to construct the confidence interval for the population mean mu like this, then the value that will go in the middle, this point estimate, okay, this point estimate will be sample mean x bar. So the point estimate is something that we get from the sample because we are using the sample to talk about the population. So we are constructing the confidence interval. The value that goes in the middle, that is called the point estimate. Now this interval from A through B, the big interval that I have shown here, this is called the interval estimate. So when we say an interval estimate of a parameter, it is the interval or range of value from A to B. When I say that, I'm talking about the range of values, okay? Range of values used to estimate the parameter. This estimate may or may not contain the value of the parameter that is being estimated. So what we have to do is, in order to tell that it actually contains the parameter, we have to be certain percent confidence on that. That's why the name confidence interval there. So before we move on to next slide, are there any questions on these two terms, the point estimate and interval estimate?
No.
Okay. So let me try to bring that picture one more time over here. Okay, we have constructed that picture there. Now we are talking about the same interval, but what I'm giving extra name here is confidence interval. When we say confidence interval, we want to say that the population parameter lies in this interval with certain confidence. So when I say with certain confidence, like I am 99% confident that the mean lies in this interval, or I'm 90% confident that the mean lies in this interval. So if we use that word, how many percent I'm confident about it, that is called the confidence interval. Okay. So what happened here is there are two things that you need to know. The first one is confidence level. So what is your confidence level? We normally denote the confidence level by C. C is equal to, if the confidence level is 90%, we write 0.90. So I'm 90% confident that the mean lies in this interval. So C is the confidence level. Okay. Similarly, if I use 95% confidence level, then in that case, C is equal to 0.95. If I'm 99% confident that the mean lies in this interval, then C will be 0.99. So confidence interval is C, or confidence level is C, I should say. Then there is another term here that is called the significance level. You can also write this. Significance label is denoted by alpha. Okay, significance label is denoted by alpha. If C is the probability that the mean lies in this interval, then the significance label alpha is the complement of that. That is the probability that it does not lie there. That means if C is equal to 90%, then alpha will be equal to, out of 90%, 10% chances that it does not lie there. So 10% or 0.10. So significance label is 0.10 if confidence label is 0.90. Now similarly, tell me, if C is equal to 0.95, what is alpha equal to?
5%,
5%.
0.05,
Very good, 0.05. Similarly, if C is 99%, what is alpha equal to?
0.01.
0.01. Very good. So you can see that in all these cases, remember that the alpha and C, when you add them together, that's always equal to 1. So alpha plus C is always equal to 1. Alpha is the significance label and C is the confidence label. And if we construct the confidence interval, or if we construct the interval with certain confidence label, then we call it confidence interval. Okay. Before we move on, do you have any question here?
Yeah, how did you get those 0.110? I mean 0.10 and
0.10, 0.05,
yeah.
0.01. Okay, so as I said before, the sum of the alpha and C will be 1, because confidence interval is the probability with which we can say that, or we guarantee that the population parameter lies in that interval. So significance label alpha is the complement of that. So total percentage will be 100. So the complement will be 100 minus that. So if C is
Oh, yeah.
90%, you got it, right?
Yeah.
90%. So the remaining is 10%. Similarly, if that is 95%, remaining is 5%. If that is
Okay.
99%, remaining is 1%. Make sense?
Yeah.
Okay, very good. Any other question from anybody in the class before we move on? Okay, look like there is no question. So we are going to look at the first type of confidence interval. So here is that. So the first type of confidence interval that we are constructing is confidence interval for mean. Whenever we are constructing the confidence interval, we are constructing that confidence interval for population mean. Okay, so when I say mean, this is the confidence interval for population mean, because confidence interval is always for the population parameter. So confidence interval for mean, that is the population mean mu, when the population standard deviation is known. If they give you the value of the population standard deviation, how we can find the confidence interval? So that is the main thing here. So we already know that if we want to construct the confidence interval, what we do is we'll have the point estimate in the middle. Okay, so in order to construct the confidence interval, first we need to have the point estimate in the middle. Then what we do is we add some value to this one to get the upper boundary of the interval, and we subtract the same value to get the lower boundary of the interval, because the value in the middle is the point estimate. So we are adding something to get the upper boundary, and we are subtracting something to get the lower boundary. So what I am adding and subtracting here is ME, or the margin of error. The value that you add or subtract, that is called the margin of error. So in order to find the confidence interval, what I need is I need the margin of error. Okay, at given confidence level, I need the margin of error. And the formula to find the margin of error is this one here. Let me try to put a box around it. You can use this formula. You can see margin of error is equal to Z sub C. So this is the Z critical, okay, Z critical, Z score. And because we have the subscript C, it is called the Z critical, but I'm going to tell you how we can find that. This sigma is the population standard deviation because that is known, and N is the sample size. Now, in order to find this Z sub C, Z critical, what we do is we use the standard normal distribution. That is something you should add in your note catcher. So we draw a standard normal distribution. When I say standard normal distribution, mean is 0, standard deviation is 1. So your mean of 0 lies at the center. Now here in this case, if I am constructing the confidence interval, you will have the confidence label 90, 95%, whatever it may be. That is the area in the middle. So remember that your C is the value over here. This is your C. C is the middle area under the standard normal curve. So C can be represented in standard normal curve like this. So C is the area, the middle area. Now you know that if C is the area in the middle, how much area is remaining on the tail? Any idea? If out of total area, if C is the area in the middle, how much area is remaining? Who can tell me? The remaining area is alpha, right? Because when you add C and alpha, that's equal to 1. So if that is 90%, remaining area is 10%. And that remaining area is divided on two parts of the tail, or they are divided on two tails. So on the left tail, you have half of that area, half of alpha. And on the second tail, you also have half of alpha like that, alpha over 2. And the value that you see in the x-axis over here, this value, let me label it. This value is Z critical. Okay, Z critical. I can use this C in the middle to represent it as Z critical. Or if I use alpha over 2, the same thing. Z critical and Z alpha over 2, they are the same thing. Okay, so we can use the margin of error formula like this, or we can write it like this. Z alpha over 2 and Z sub C are the same. So that is your Z critical. So if I want to find this one, it is just the negative of that, negative Z critical. And in order to find this Z critical, you know that whenever you want to find the value along the x-axis, we'll use inverse normal in our calculator. Inverse normal, then area to the left, okay, area to the left, then mean, and then standard deviation. So that's how we can find this Z critical. So once we know the Z critical, see, once we know the Z critical, this one will be given because that is known. We'll have the sample size. So when we calculate this, we get the margin of error. So if we add that margin of error or subtract the margin of error to the point estimate, we'll be able to construct the confidence interval. And with certain confidence, we can say that The true mean or the population mean lies between these two values. So that is the basic idea of the confidence interval. Before I move on to the second bullet point here, do you have any question on the first? Any question?
Yeah, so excuse me. So for the area shaded in red, is that alpha divided by 2 or is it alpha divided by z?
Alpha divided by 2, because the remaining area, when you have C in the middle, remaining area is alpha, and that alpha is divided into two parts. So it's alpha divided by 2. For example, if the middle area is 90%, the remaining area is 10%. That 10% will be divided into two parts, right? So the
Yes.
values on the tail will be alpha divided by 2. Make sense?
Yeah, and then that's what that equals z.
And the value that corresponds to that here on the x-axis, that is the z critical.
Okay, I see.
The value on the x-axis, okay? The value
Gotcha.
on the
Okay, thank you.
x-axis, yeah, the value on the x-axis that separates the middle area from the area on the tail, that is the z critical, okay?
Gotcha. Thank you.
You're welcome. Any other question from anybody in the class? Okay, no question. That's good. Now you can see that in order to construct the confidence interval, we need a sample. So what should be the proper sample size in order to construct the confidence interval? So if we want to find the sample size, we'll use this formula to find the sample size. Let me rewrite that formula just that so that it looks a little better for you. N equal to, as I told you before, z sub alpha over 2 or z sub c are the same thing. So for this one, you can write z sub c times the standard deviation divided by margin of error squared. So in order to find the sample size, we use this formula. This formula will tell you the required sample size, a minimum sample size that is required to construct a confidence interval with certain confidence level is given by this. Sometimes when you try to find a value using this, we may get a decimal value. But remember, if we get a decimal value for the sample size, because sample size means you are counting the individual cannot be in decimal, so you have to round up to a whole number. You have to round your answer up all the time. We don't round it to nearest number here for sample size. Remember that? For sample size, we round it up to a whole number. So that is how we can find the sample size to construct the confidence interval. Okay, let's take an example so that this will be more clear. So we are going to begin with this example here. Let's see what is given. The age when smokers first start from previous study is normally distributed with the population standard deviation of 1.8 years. And a survey of smoker of this generation was done to estimate the mean. The sample of 35 smokers found that the mean starting age was 14.7. We have to find the confidence interval for the mean, and that should be 95% confidence interval. So here, what they have given is the age when the smokers first start from the previous studies is normally distributed. So if we talk about the age of all smokers in the world, then that population is normally distributed with the population standard deviation of 1.8 years. So their standard deviation of the population is 1.8 years. So that is your sigma. Okay, sigma is 1.8 years. Sorry about that. A survey of smokers of this generation was done to estimate the mean age. So you want to estimate the mean starting age when they start. And for that, there is a sample of 35 smokers. So this is your N. Okay, sample of 35 smokers found that their mean starting age for this sample, the mean starting age or the sample mean is 14.7. We have to find the 95% confidence interval. So as I said before, in order to construct the confidence interval, what we need is, okay, What we need is, we need the point estimate in the middle. In this case, we are talking about the mean. So sample mean will go in the middle, and we add the margin of error to get the upper boundary for the interval, and we subtract the margin of error to get the lower boundary for the interval. So in the question, they have already given this one. They have given this mean. Mean is 14.7. Mean is 14.7. But what we don't know is, we don't know this margin of error. If we know the margin of error, then we can add and subtract that margin of error to get that confidence interval. But what we know is, let me write, we have the margin of error is given by this formula. Margin of error is equal to z sub c multiplied to sigma over square root of n. That is the formula from the previous slide. So this one, sigma is given 1.8, n is 35, that's also given, but we don't know this one. We don't know z sub c. So what you have to do is, we have to find the z critical, then we have to plug in here to get the margin of error. Then we will be able to add and subtract the margin of error to get the lower and upper boundary for the interval. So before we move on, is everything clear up to here? Yes, no?
Yes.
Okay. So now let's try to find the z critical. So for that, we start with the standard normal distribution. When I say standard normal distribution, your mean is 0 and standard deviation is 1. So along the x-axis, we have the z-scores. And here we are talking about 95% confidence interval. So the area that goes in the middle is the 95% area. So you can show your 95% area in the middle. So this is your C equal to 0.95. The area in the middle is 0.95. So if the area in the middle is 95%, what is the remaining area?
5%.
5%. And what we are doing is, we are dividing that 5% on 2 tails. So what is 5 divided by 2?
0.25.
So 2.5% or 0.025. So this is alpha over 2 equal to 0.025. So same thing here. This is also alpha over 2, which is equal to 0.025. Okay. And the value that goes here, that is the z critical. This is your z critical, and this is the negative of that. So we have everything set up. All you have to do is, we have to use our calculator and find the value of z critical. Okay, we have to use our calculator to find z critical. So what we know is, here z critical is equal to, if I want to find the value along the x-axis, if I want to find the value along the x-axis, do I use normal distribution or inverse normal?
Inverse normal.
Inverse normal, very good. Inverse normal. Then what we do is, we look for the area to the left. So if I want to find this one, z sub c, everybody look at the screen. If I want to find this z sub c, the area on the left is, in the middle you have 95%, and here you have 2.5%. So you have a total of 97.5% area on the left, which is 0.975. That is 97%, right? 0.975. Mean is 0 and standard deviation is 1. So now you can use your calculator to find that area. Do you want to try it? Let me try to share my calculator if possible. Can you see my calculator there?
Yes.
Yes. So you'll do second, and then you go to vars here, and you go to inverse normal, which is number 3. Then you put the area, which is 0.975. Your mean is 0. Standard deviation is 1. Then you'll paste that and hit enter. So what do you get? Do you get the same value as I got?
Yeah, 1.9600.
That is right. So that is the value of the Z critical. Okay, that's your Z critical. Okay, let me try to share back the other screen. I think I need to stop sharing this one. Okay. Can you see my screen now?
Yes.
Yes. Okay. So what we got is Z critical is equal to 1 point how much? 96, right?
Yes.
If I just want to round it to 2 decimal places, 1.96, or you can go up to 4 decimal places. So 1.96 is the value of Z critical. So the reason I was calculating this Z critical is to plug in here and find the value of margin of error, right? So if I do that, see, now plug in Z critical is 1.96 multiplied to the population standard deviation sigma is 1.8 divided by square root of 35. Now, if you simplify this using your calculator, make sure you do it, you should get 0.5963. So the margin of error is 0.5963. That means to this 14.7, we can add 0.5963 or we can subtract 0.5963 to get the upper and lower boundary for the interval. So we can write like this. Now lower boundary will be, you have seen that, lower boundary is the mean in the middle minus margin of error, this one, this minus margin of error. So 14.7 minus 0.5963. 0.5963. So if you subtract, what you will get? Please try. If you subtract, what you will get? Are you working on your calculator? 14.7 minus 0.5963.
14.10.
14.1037. Is that what you said?
Yes.
Okay. So similarly, if I want to find, that's right. Now, similarly, if I want to find upper boundary will be X bar, the mean, plus margin of error. So that is equal to 14.7 plus 0.5963. Okay, so now please use your calculator, add those two values and tell me what you'll get. That will be the upper boundary. What do we get when we add?
15.2963.
15.2963, that's right. 15.2963. So meaning of that is we are looking for the average starting age of the smoker, right? When they start. So the mean lies between these two values. So the confidence interval will be, see, we can write like this. Confidence interval is, you can write it as 14.1037 up to 15.2963. So here we have shown the confidence interval on a number line. Here we have written in the form of an interval like that. You can write it like this, or we want to say that the population mean lies between those two values. Population mean lies between those two values. So the other way of writing the interval is we can write it as 14.1037 is less than the population mean, which is also less than 15.2963. In other words, what we are saying is the population mean lies between these two values. That's what we are saying. Or one other way of writing the confidence interval is what we have done is to this 14.7, we have added and subtracted the margin of error. And margin of error is 0.5963. So that is the other way of writing. So there are three different ways of writing the confidence interval. So when you're solving your mastery exercise, when you look at the box where you have to put the answer, you can clearly see if it begins with parenthesis like this, you have to give the answer in first form. If you see the inequalities like this, you have to give it in second form. If you see plus or minus in the middle, then you have to give your answer in third form. Okay, so that is the meaning. And that's how we write the confidence interval. And meaning of this confidence interval is, let's try to interpret this because we are doing this for the first time. So we can say that with 95% confidence, make sure you write this down. With 95% confidence, we conclude that the population mean lies between these two values, which is 14.1037. In this case, it is the years, and 15.2963 years. So the true mean lies between these two values. That is the meaning of that. And we can say that with 95% confidence. Any question on that? No question? Okay, so that is the first example. Here we learn how to construct the confidence interval. But if we go back to the theory that we have studied here, we learn two things. The first one is constructing the confidence interval. Second one is to determine the sample size. What should be the minimum sample size if I want to construct a confidence interval with certain confidence level? So next example will be finding the size of the sample. So let's look at that. Here is the example. So let's go through first, read through. You are interested in estimating the mean age of the citizen living in your community. Okay, you want to find the average age of the people living in your community. In order to do this, you plan on constructing the confidence interval. So what you're trying to do is you want to make a confidence interval and you want to be certain percent confidence, 96% confidence here. So with 96% confidence, you want to say that the mean age of people in my community is between these two values. Okay. However, you are not sure how many citizens should be included in the sample. So that means we don't know about the sample size. So we need to find that. If you want your sample estimate to be within 4 years, so when we say sample estimate within 4 years, that means from the point estimate, you are adding and subtracting 4 years. That means that 4 years is your margin of error. So when we say sample estimate to be within 4 years, that means 4 years is the margin of error. You can label it as ME, margin of error. with the confidence level of 96%. Confidence level 96%, that means C is equal to 0.96. Okay, confidence interval or confidence level 96%. C is equal to 0.96. How many citizens should be included in the sample? We need to find that. Assume that the standard deviation of all the citizen means the mean. I mean, all means population, right? Standard deviation of all citizens in the community is 25 years. That is standard deviation sigma is 25. That is the meaning of that. When we say all, we are talking about population. So clearly what you can see here is you want to find the sample size. So for that, you know the formula. But before that, let me write what is given in the problem. They have given the margin of error, which is 4 years. We have seen that. Confidence label, 0.96. And the population standard deviation, 25 years. That is the piece of information or the information given in the problem. Now we want the sample size. So we know the sample size n is given by the formula z sub c multiplied to sigma divided by margin of error squared. That is the formula. So if you look at this formula, margin of error is given. We can plug that in for sigma. The standard deviation is 25. That's also given. But z critical, we don't know what is that. So we need to find the z critical at the confidence level 96%. So to find the z critical or to find the z value, you have to draw the normal distribution. So let's draw that normal distribution. Okay, here is my standard normal distribution. So you can label it with the mean 0 and standard deviation 1 along the x-axis. You'll have the z values. We are talking about the 96% confidence level. So the middle area is 96%. You can show the middle area as 96%. So this is C equal to 0.96. And you can label that. If the area in the middle is 96%, what is the remaining area? How much area is the remaining area?
4%.
4%, and that is divided into two parts. So 2% each on the tail, right? So alpha over 2 is 2% or 0.02. And same thing here. Alpha over 2 is 0.02. So this value that separates the middle area from the area on the tail, that is your Z critical. So these values, Z critical, this will be negative of that. And if you use your calculator to find that Z critical will be equal to inverse normal and area on the left of this Z critical. If you look at the screen, please look at the screen now. Area on the left of Z critical. Here the area in the green is 96%. Area in red is 2%. So if we add everything on the left of Z critical, that is 96 plus 2 or 98%, which is 0.98. Mean is 0, standard deviation is 1. So if you use your calculator, please use your calculator and tell me what you'll get for Z critical. Use inverse normal on your calculator and tell me what will be the value for Z critical.
2.0537.
2.0537. Yes, that's right. 2.0537 is the Z critical. The reason we are calculating this Z critical is to plug into that formula there. So let's plug in and find the value of sample size. So this implies your N is equal to 2.0537 multiplied to standard deviation is 25. Margin of error is 4. So you have to type all this inside the parenthesis, close the parenthesis and square it. So please use your calculator again. Type all these values inside the parenthesis, square it, and tell me what you'll get. Good. I hope you're typing it. Okay, what do you get?
We rounded to the whole number is 165.
So without rounding, what do you get? Just tell me without rounding first.
164.7533.
Okay, that's right. So 164.7533, but this is the sample size. We round it up, so it will be 165, right? So the required sample size is 165. So let me write down. So the required sample size is n equal to 165. So if you want to construct the confidence interval with certain confidence, in this case 96% confidence, then you must choose 165 as your sample size. When you do a survey of 165 people in your community, then you'll be able to tell their mean is with 96% confidence level. That is the meaning of that. So any question on this example?
No.
Okay, good. So you can see that in these two examples, one thing was true. In both of them, you can see this population standard deviation sigma is given. Even in the first one, you can see the population standard deviation sigma is given because we were looking at the confidence interval for the mean when sigma is known. When we say sigma, it is the population standard deviation. For example, if I want to know the average, okay, average amount of meat consumed in a household in our country, then I'll not be able to reach to every single individual and get the data. I may not have the population standard deviation. Okay. So it is not easy to get that population standard deviation all the time. So in general case or in real world, this population standard deviation will not be known. It will be unknown. So if sigma is unknown, how we can construct the confidence interval? We are going to look at that now. This one here. So confidence interval for mean when the population standard deviation is unknown. So population standard deviation is unknown. So everything remains the same. But what happened is when population standard deviation is unknown, then the distribution of the sample mean will not be the z distribution, will not be able to find the z value. Instead, it is going to be the t distribution. When I say t distribution, your t distribution will look similar to z distribution, but the difference you'll see is if I try to draw the t distribution with t values, just like the z values along the x-axis. Okay, let me redraw it. If you look at the diagram, you'll see that the diagram will be a little bit taller compared to z distribution. This one, t distribution will be a little bit taller. Along the x-axis, you'll have the t values. Here, we don't talk about the mean and the standard deviation. Instead, we talk about the degrees of freedom. We talk about degrees of freedom. It is just a fancy name given to the sample size minus 1. So when I say degrees of freedom, it is n minus 1. Okay, degrees of freedom is always equal to the sample size minus 1. So what we do is, in order to find that margin of error, when you are certain percent confidence, your C will be in the middle, no doubt on that. Your C will be in the middle. Remaining area, which is alpha, excuse me, that alpha will be divided into two parts like this, alpha over 2 on the tail. But the value over here on the x-axis will be T critical. This is your T critical, and that will be negative of that. And in order to find T critical in our calculator, we use inverse T. We use inverse T. When you go to same place, when you do second inverse, in the list, you will see inverse T. Then you'll take area on the left of T critical. Okay, area on the left of T critical. And then you have to put the degrees of freedom. This is how you can find T critical on your calculator, because the distribution will be T distribution. And when you try to find the margin of error, your formula will be like this. Margin of error is equal to T critical. In place of Z critical, this is going to be T critical. Okay. And then in place of the population standard deviation from the sample, when you know the sample, you can easily find the sample standard deviation divided by square root of n. So you can see that there are a little bit of new things here. When we check examples, this will be clear. I'm going to show you how to find that inverse T on calculator and all those things. Before we move on, do you have anything to ask here? Okay, look like there is nothing. So let's go here. Let's try to solve this one. Karen wants to advertise how many chocolate chips are in each big chip cookie at her bakery. She randomly selects a sample of 75. So that is the sample size, n equal to 75. Okay. And finds that the number of chocolate chips per cookie in a sample has a mean of 16.5. That is the sample mean. So n equal to 75, you can label it. N equal to 75. 16.5 is the sample average. And for that 75 cookies, the standard deviation is 3.4. Or the standard deviation of the sample, that is S, is 3.4. What is the 90% confidence interval? So we are looking for 90% confidence interval. So C is equal to 0.90. So if I want that, see what is given here is, if I want to write all those things down, n is equal to 75. Sample mean is 16.5. Sample standard deviation S is 3.4. And we are looking for the confidence interval with 90% confidence level. So we are looking for 90% confidence level for the mean. But if we look at this one, the population standard deviation is not given. So when population standard deviation is not given, the distribution will be T distribution. That is something to know. But before that, let me draw that confidence interval. We have the sample mean in the middle. That is 16.5. Then we need to add the margin of error to get the upper boundary. And also we have to subtract the margin of error from the point estimate to get the lower boundary. But to find the margin of error, what we have is, because the population standard deviation is not given, the margin of error is given by the formula. Okay, margin of error is equal to T sub C multiplied to S over the square root of n. This formula here, T sub C multiplied to S over the square root of n. Now, if you look carefully, the value of n is there, 75. Value of S is there, 3.4. But value of T sub C is not there. So what you have to do is, we have to draw the T distribution and find the value of T sub C. So first, let's draw the t distribution at the side with t along the x-axis. And as I said, when you draw, it should be a little bit taller compared to the z distribution. So it will look something like that. So that is your t distribution. If this is a t distribution, you must know the degrees of freedom. Degrees of freedom is sample size minus 1. See here, sample size is 75. So what is the degrees of freedom? If n is 75, what is the degrees of freedom? Come on, beautiful people.
74.
74.
74, very good. All of you know this, 74, very good. Now we are looking for 90% confidence level. So the middle area is 90%. So you can show that middle area C as 90%. So C is 0.90. That is the area in the middle. And the remaining 10% is divided on the tail. So 10% is divided on 2 tails. So 5%, which is 0.05. And these values here, they are the critical values. So we can write them as T critical like that. This one will be negative on the left. Okay, let me try to put that negative there. There we go. So now, in order to find that T critical, we use inverse T in our calculator, inverse T. And if we want to look at the area on the left of this one is, the area in the green is 90%, area on the red is 5%. So 90 plus 5, 95% area is on the left. 0.95. That's one way of looking at it. The other way is this. See, here is your T critical. The area on the right is 5%. If the area on the right is 5%, the remaining area is 95%. So 0.95. Then you have to write the degrees of freedom, which is 74. Degrees of freedom is 74. So now let me try to show or share my calculator here. Give me 1 second when I try to do that. Share my calculator. Let me stop sharing this. Okay, can you see my calculator?
Yes.
Okay, so what you do is you go to second, and then you go to same place, vars, and you should see inverse T here on number 4, right? Inverse T, so click number 4. And once you do that, type the area on the left. We have said that it is 0.95. Degrees of freedom, we have seen it is 74. And then you come down and paste that information on the main screen. It just looks like the way we have written on the paper. Then hit enter to get the value. Okay, so we got the value there. So what is the value? You can write it as 1.6657, right? 1.6657. That's what you can write it down. So that is the value of T critical. So let me share back my other screen here. Let's see. Okay. Stop sharing the calculator. So can you see my screen?
Yes.
Okay, so we got this value of T critical 1.6657. Before we move on and calculate margin of error, are there any questions so far?
No.
No question? Okay, that's wonderful. So now we'll plug in the value and find the value of that margin of error. So first, we put this value, T critical. We got 1.6657. Then multiply to S. The value of S is 3.4 divided by square root of 75, N is 75. And if we simplify that, we get 0.6540. Make sure you check it. So that is the value of the margin of error. So we plug in the values and we got the margin of error. So that was the first thing. Once we get the margin of error, now you can add and subtract the margin of error to get the lower and upper boundary for the interval. So now let's find the lower boundary for the interval. Lower boundary will be equal to, the value in the middle is 16.5 minus, we are subtracting 0.6540. So when you subtract that, it should be 15 point, make sure you check it, 15.8460. Similarly, the upper boundary will be, upper boundary will be 16.5. Okay, let me write the lower boundary on the diagram first, 15.8460. Now for the upper boundary, we add that plus 0.6540. So make sure you add using calculator. When you add these two numbers, it should be 17.1540. 17.1540. So that is the lower and upper boundary. So your confidence interval is, confidence interval is from 15.8460 up to 17.1540. That means with 90% confidence, okay, with 90% confidence, we can say that the mean lies between these two values. So let's write that conclusion there. With 90% confidence, we can say that the mean lies between 15.8460 and 17.1540. Any question on this one?
I got a different number.
Which number you got different?
I got 0.6545, not 40.
0.6545, is that what you got?
Yeah, that's
Okay. Let me quickly check that here. Maybe sometimes I make a mistake. So 1 point, I'm just typing it. 6657. You said the margin of error, right?
yes.
Okay. Multiplied to standard deviation is 3.4. And then we divide that by the square root of 75. Did you put 75?
Yes, sir.
Okay.
I think maybe it's the brackets, because when I didn't put brackets in there, I got a different answer. But when I added brackets around the 3.4, divided the
Okay.
square root of 75.
Right. So what do you got? You said you got 6.653.
I got 0.6545.
6545. Okay, that's interesting. Let me
Oh,
type
whoa, wait. It may be
it.
me.
Yeah, you can also try there one more time. That's totally fine.
I'm missing a number in my first one. Okay, it makes
I
sense now.
saw.
I was like, wait a minute, what's wrong? I got
Yeah,
it.
that happens when we play with calculator. That's totally fine.
Thank you.
You're welcome. Okay, so that is resolved. That's correct. So besides that, any other question? Okay, look like there is no question. So you can see there are three different types of confidence interval that we'll be constructing. The first one, when the population standard deviation was known. And the second one that we have just seen is when the population standard deviation is unknown. The second one is more realistic because in real world, we'll not be able to, get that population standard deviation. Okay, when we have the sample, we get everything about the sample, but it's not easy to get the population standard deviations. The second one is more realistic in real world. So second one make more sense. There are three of them. The next one is the um, confidence interval for proportion, and we'll be doing that proportion in next class. That means we are going to end this class here with the attendance. So do you get the link for the attendance in the chat? Please check it.
Yes.
Okay, so please complete the attendance. And that's all for today. When we come back on Thursday, we are going to complete this unit by completing the confidence interval for proportion. Okay.